Okay, today what we're looking at is something that's new for some of you, especially if you came from 2P. 2Ds, you would have looked at this a little bit in 2D course last year. So today's topic is the sine law for non-right triangles. Okay, so our goal is I know how to solve for sides and angles in non-right triangles using the law of sines. So it's section 4.4 and it is section A. There is a section B which is going to deal with actually word questions dealing with the sine law. So exactly what is the sine law? Well, first of all, the reason we are studying it is because not all triangles are right triangles. The world is not made up of right triangles. And the primary trig ratios can only be used when you have a right triangle. Okay, so it limits us in what we can do. But we can use our primary trig ratios to develop some formulas. Notice it's plural, so we will look at another formula another day that will work for all triangles. So these laws, this sine law works for right triangles as well as non-right triangles. Okay, so this is the sine law for any triangle ABC, where A, B, and C, little c's, are the opposite sides opposite of angles A, B, and C respectively. The sine law states that if you take the sine of angle A over side A, that will equal the sine of angle B over side B, which will equal the sine of angle C over side C. Now the formula can be written like this, or it can be flipped around and it does the same thing. And what I mean by flipped around, it means that I could write it a different way. And the way that I could write it is, get back in place there, is I could write it as side A over the sine of angle A equals B over the sine of angle B, which equals C over the sine of angle C. Okay, so either way works. You can use either one. Some people like one way or the other, and often I do just a little survey and I ask everyone in the class which way do they prefer. Some people's brains prefer this way, some people's brains prefer that way. So as I said, it works either way. And what I'll do is when I do examples, I actually will do one way and I'll do the other one, solve it using the sign in the other location. Okay, so first of all, I'm not going to just give you the formula. Let's find out, why does this work? Okay, so this is a proof, a little mini proof, and we're given triangle A, B, C, and you can see it's drawn for us. And what we're going to do, you can see, first of all, it's not a right angle triangle, which is good because we don't want to start with that. But I'm going to draw a perpendicular. And what I mean by perpendicular, I'm going to drop down a perpendicular here. And I'm going to call that this D. And by doing that, AD is the height of the triangle. And I have now effectively created two right angle triangles. We all can see that. Okay, so when we're talking about this, what we're going to do is we're going to call this H, because that's the height, that's the perpendicular height of this triangle. And I'm going to use the original angles to get the side. So I'm going to call this side C because it's directly across from angle C, the big triangle C. This directly across is B. Now A, I'm not going to do it for because I have actually cut side A, which is BC, in two different parts. So I've now created two right angle triangles. So we're going to look at both triangles and we're going to actually come up with the formula, the sine formula from them. Okay, so this is what they would have done years ago when they actually discovered this relationship. Okay, so first of all, we're going to do as soon as I get my pen where I want, Up a little bit higher. So in triangle A, B, D, so I want to look at angle B, and I want to make a relationship with it, with that angle, and the hypotenuse, sorry, the H, which is the height of the triangle, and side C. Okay, so what I'm after here, this is H. This would be opposite of my B. And this would obviously be adjacent, and I'm not interested in that right now. So if I have the opposite and the hypotenuse, I know that is sine law, sorry, sine primary ratio. So that would be the sine of angle B would equal the opposite, which in this case is H, over the hypotenuse, which in this case is C. Okay, so that's all I've done. Now, what I want to do now is I want to solve for H because H is a common side between my two right angle triangles that I've created. So the way to do that is I would multiply both sides by C. So I would have C sine of B equals H. Okay, now what I'm going to do is I'm going to look at the other right angle triangle that we've created. And so I'm going to go in triangle ACD. What I'm interested in is this time I'm going to look at angle C. And again, this is its opposite side. This is across from the hypotenuse, so this would be its H. And again, opposite and hypotenuse, so I'm going to use sine again. So this time it would be sine of angle C would equal H again over B. So I'm going to solve for H again. So I'm going to multiply both sides by B, and so I end up with B sine of C equals H. Now what we have discovered here, that both of these equal H. And H is the same H right here. This is the H that we're talking about. So what we have found then is since both expressions are equal to H, they must also be equal. And they, I'm referring to the expressions. They must also equal each other. Okay, so what that means is the C, and I'm just going to bring this down again. So because this H and this H are the same thing, that means that C sine of B must equal B sine of C. Okay, and you're saying, okay, big deal. That still doesn't look like a formula to me. Well, watch what happens here. What I'm going to do is I'm going to multiply this side by, sorry, divide this side by B, which means I also have to divide this side by B. And if I do that, we know what happens is this B crosses out, and I'm left with, on this side, C sine B all over B equals sine of C. And then what I can do is I can divide both sides by c, and by doing so, it crosses out the c's on the left-hand side, and now I'm left with sine b over side b equals sine of c over little c. Okay, so that is the beginning of our actual formula. So then what happens is if we draw another altitude to a different side, so if I went back to my triangle and I actually said, okay, let's draw perpendicular from here down to here, I could actually again do the same process, and I would be using another set of angles, and I would get A into my situation. So we could do the same process to see that side A and angle A are involved in the same ratio. So we have developed the sine law. So that's how they developed it years and years ago, centuries ago. So now just a little brief warning. And the warning is that, and I'm just going to bring up my star. Oops, get that out of the way. That the problem happens here is it only works for obtuse angles. Okay, so it only works for obtuse angles, and that's in, sorry, it doesn't work for obtuse angles. Doesn't. Okay, so only acute angles. So only for triangles that all the angles are less than 90 degrees. Okay, the reason being, it's not that it doesn't quite work for some triangles that are larger than 90 angles. It's just that there's something else that we'd have to watch out for. So in other words, you should never use the sine law to find the angle opposite the largest side of a triangle, just in case it's obtuse. Sometimes we don't know if we're dealing with obtuse or not. Okay, so note, to use the sine law, you must have a side and its opposite angle. Okay, so it means if I have a triangle, I would have to know a side and the angle directly across from it. Okay, so it has to be that kind of situation. And it doesn't matter whether it's this side and that angle. Okay, so in order to use it, you would have to know a side and its angle directly across from it. So what we're going to do now is we're going to actually solve this triangle. It says using sine law to solve non-right triangles. And remember, solve means to find all missing measures. That's all angles, all sides. Okay, so that's what we're going to do now. And I'm just going to stop the video and we'll do our examples now. And then tomorrow you can do some work in class.